Good evening everyone, good evening. I welcome you all again to JEE Enthuse. I hope you guys are doing great, having a good time guys. Let me know in the chat box if I'm audible and visible to everyone. Hello Ashwini, hi Nisha, hello ABCD, yeah? Hi Manisha, hi Emmanuel. Hello Ashwarya, hi Yazini, hi Tornado, hello Akash. Hi Janet, hi Ranjit, hi Abhi. Welcome everyone, welcome back to your JEE Enthuse, yeah? Just let me know in the chat box if I'm audible and visible to everyone, right? Let me know fast, let me know fast, let me know fast. Yes, Tornado, there might be some lag, right? There are certain issues. I'll fix it tomorrow, yeah? But it's fine, I guess. Perfect. So people, as you all must be knowing, tonight it's going to be our 14th mock test for JEE 2021 from your complete chemistry, yeah? Yes, right? Perfect guys, exactly. Today it's going to be our 14th mock test. Till now we are done with 13 mock tests, yes. And tomorrow in the morning at 9 or 10 maybe, you can see it in the thumbnail, I'm going to take the formula revision of your complete chemistry as well, right? So before starting the session, the ones who are new to the channel, let me introduce myself. My name is Wassim Bhatt and I'm your chemistry master teacher writer on this JEE Enthuse channel, yeah? Perfect. The ones who have not liked the video yet, please do like the video, share the video with your friends, and do not forget to subscribe to the channel as well, and do not forget to hit the bell icon so that you get the notification of every single session which we take live on this JEE Enthuse channel, yeah? So do like the video, do share the video with your friends, and do subscribe to the channel as well, yeah? Okay. So people, let me know in the chat box if you guys are super duper excited about the session. Let me know fast with some thumbs ups, with some fire signs, yes. Let me see the josh of the session first, then only you'll be starting the session directly without wasting a lot of time. Yes, Arshil, I'm going to break the records of taking mock tests, yeah? Perfect, let me know fast. Should we start the session? Yes. Wonderful guys, good job. Perfect, so let's get going with the first question of your rank booster JEE 2021 complete chemistry mock test 14, which is going to be on your screen in 3, 2, 1 and now. This is the first question on your screen. The question directly taken from your NCERT, right? NTA question. An example of the halide ore is. Which one of the following is the example of the halide ore? Let me know fast. Which one of the following is the example of the halide ore? Well, people are coming up with option C, option D, yeah? Give it a try, let me know its answer fast. An example of the halide among the following. It's going to be, guys, let me tell you exactly, majority of you are perfectly correct. It's going to be cryolite, yes? Cryolite is the example of the halide ore. Remember, these sort of questions are frequently asked nowadays, as I keep on telling you, from your NCERT, okay? Remember, cryolite, it is the halide ore. Galena, it is the sulfide ore. Cinnabar, it's the sulfide ore. And at the same time, your bauxite, it is the oxide ore. Remember this thing as well. These things are really important, okay? Right? Because if you'll see the previous few attempts of your JEE Mains, yeah? Majority of these sort of questions were asked, and these sort of questions are directly taken from your NCERT, yeah? Perfect? Yes? Okay, so let's move on to one more question which is on your screen. The shape around the central metal in ClF4 positive. ClF4 positive. The shape around the central metal in ClF4 positive. What do you think about this? Give it a try, let me know fast. Yes, Shiva, I'll be resuming the atomic structure for class 11 people as well, but currently, our first priority is the JEE 2021 because they have got the exam scheduled in this month, in next week only, okay? Right? We will be starting again the class 11 series, do not worry, we are here with you, okay? But currently, JEE 2021 is the preference, yeah? Okay? Alright, so let's see what is going to be the correct answer of this question. We are given with the molecule as ClF4 positive. ClF4 positive, correct? First thing, This chlorine is the central atom. It has got some 7 valence electrons, but there is a positive charge as well. So 7 minus 1 is equal to 6, right? How many sigma bonds are being formed over here? There are some 4 sigma bonds being formed, right? Chlorine, it has some 6 valence electrons. Out of 6 valence electrons, it has used some 4 of its valence electrons to form the bonds. So there will be 2 electrons left as such on chlorine. So how many lone pairs will be there? There will be 1 lone pair, right? 4 bond pairs, 1 lone pair. 4 sigma bonds, 1 lone pair, right? 4 sigma bonds, 1 lone pair, correct? What is going to be the steric number? Steric number is basically sigma plus lone pair, 4 plus 1, 5. The hybridization is going to be sp3d. Which d orbital is involved in hybridization? It is dz square, right? What is going to be the type of the molecule? It's going to be AB4L1, and in case of AB4L1, what is going to be the shape? It is going to be seesaw, right? 4 bond pairs, 4 sigma bonds, 1 lone pair, right? Similar as that of your SF4, yeah? Yes, the shape around the central metal in ClF4 positive is going to be seesaw, right? Perfect. Exactly, guys, exactly. Let's move on to one more question. I'm sure it's clear to everyone, right? Let's move on to one more question which is on your screen. Which of the following has the highest magnetic moment? Which of the following has the highest magnetic moment? Give it a try and let me know its answer. Which of the following has the highest magnetic moment? Ti tripositive, Sc tripositive, Mn dipositive, Zn dipositive. Which one of the following has the highest magnetic moment? Isn't it a very simple question, guys? Yeah? Yes. Just write the outermost configuration. That's it. You're done. If we talk about the outermost configuration of Ti, Sc, Mn and zinc, as you can see right here, the outermost configuration of Ti is 3d2, 4s2, but this is Ti tripositive, so you are going to take 3 electrons out. So take 2 electrons out from here, 1 electron out from here. So Ti tripositive configuration becomes 3d1. Yes. Similarly, scandium, 3d1, 4s2, but this is scandium tripositive. Take 3 electrons out. Take 3 electrons out, 2 from here, 1 from here. So it becomes a 3d0 configuration. Mn, 3d5, 4s2, manganese, 3d5, 4s2. But this is Mn plus 2. Take 2 electrons out. 2 electrons are taken out from here. So this is 3d5, 4s0. Similarly, Zn dipositive is 3d10, 4s0, right? Now check which one has got the maximum unpaired electrons. This one has got the maximum unpaired electrons, 5 unpaired electrons, right? And we know wherever the unpaired electrons are maximum with the central atom, there only magnetic moment is going to be the maximum, right? So it's absolutely going to be Mn dipositive, which is going to have maximum magnetic moment, right? Yes, I'm sure it's clear to everyone, right? Let's move on. Let's move on to one more question then. Yeah, this is one more question on your screen. You can solve it easily. A very simple, basic, ordinary question. Yeah, give it a try. Yes, Joy, I know there is some issue. I'll take it out. Let me know fast. Let me know fast. Give it a try. Give it a try, guys. It's a very simple question, yeah? Arrange the following given acids in decreasing order of their Ka values, right? So basically, you need to arrange them on the basis of their acidic strength. More the Ka, more is going to be the acidic strength, right? More the Ka, more is going to be the acidic strength. Now you need to arrange them on the basis of their increasing acidic strengths or decreasing acidic strengths. Let's see. See guys, first of all, as you all must be knowing, acidic strength of the acid is directly proportional to minus effect. It's directly proportional to minus effect, right? Yes. Okay. Now we will have a look. This is fluorine right here. This is chlorine. This is NO2. This is Cn, right? So which one shows maximum minus I effect? Which one shows maximum minus I effect? Cn, NO2, Cl or F? Can you let me know in the chat box? Which one shows maximum minus I effect? Can you let me know? Is it going to be NO2 or Cn? It's going to be NO2, right? So this one shows the maximum minus effect, minus I effect. So this one will be maximum acidic. So R is going to be maximum acidic. Then comes your what? Then comes your Cn, right? Then comes your Cn. Then comes your S. Yes. Now among fluorine and chlorine, which one shows more minus I effect? It's going to be fluorine, so it's going to be P. Then at the end, it's going to be Q, right? Yes. So option D is the one which is correct among all. Yeah. Okay. Exactly, guys, you all are perfectly correct. It's going to be option D, which is the answer of this question, because acidic strength is directly proportional to minus effect, yes, and minus I effect of NO2 is maximum, followed by CN, followed by fluorine, followed by chlorine, right? Yes, perfect. Let's move on to one more question then. Okay, this is not the question, this is the minus I series. I want all of you to take a note of this, right? This will help you a lot, okay? Take a note of this, take a screenshot of this is important. This is the minus I series, yeah? Perfect, guys. Moving on to one more question. For two weak acids A and B, the ratio of their percent ionization is 4:9. The ratio of their Ka values would be. What is the ratio of Ka? People, it's a simple equation. For weak acid HX type, for weak acid HX type, okay, first of all, let me tell you, your weak acids, weak bases, sparingly soluble salts, these are considered to be as the weak electrolytes which remain in equilibrium with its ions. Its ions are H positive aqueous and X negative aqueous, right? Let's say its concentration is C, this is 0, this is 0. Let's say degree of ionization is alpha, so it's going to be C minus C alpha, this is going to be C alpha, this is going to be C alpha. If I write the Ka expression, it's going to come as C alpha square divided by 1 minus alpha. All of you must be knowing with this, yeah? Right? Now people, first thing, let me tell you. Can I say Ka is directly proportional to basically C alpha square? Yeah? Can I say Ka is directly proportional to C alpha square in case of weak electrolytes? I can say that. Right? I can say that. So I can say something like this: Ka1 divided by Ka2 is equal to alpha 1 square divided by alpha 2 square, right? This is the ratio which I need to calculate. What is alpha 1 ka square? It's going to be 4 ka square. What is alpha 2 ka square? It's going to be 9 square. It's going to be 16 divided by 81. So ratio of Ka1 to that of Ka2 comes out to be 16 is to 81, which is going to be option C, right? All of you are perfectly correct, guys. All of you are perfectly correct. Exactly. Right. Wonderful. Let's move on to one more question then, yeah? Let's move on to one more question then. This is one more question, a very simple question from the chapter Coordination Chemistry, yeah? Right? Give it a try. Let me know its answer. We are supposed to calculate the effective atomic number, EAN. EAN of zinc we are supposed to calculate in this complex. Well, people, there is a simple formula by means of which you can calculate the effective atomic number. You know it. You all must be knowing it, right? The topic directly from your NCERT. Yes, an NTA question by means of which you can guess the level of the coming JEE 2021 examination. Yeah. Okay, so let me tell you, the effective atomic number is calculated by this formula. Effective atomic number of the central atom is basically equal to atomic number of the central atom minus oxidation state of the central atom, number of ligands multiplied by 2 multiplied by density. Okay, this is how we calculate effective atomic number. Have a look. What is the atomic number of zinc? Atomic number of zinc is 30, right? Minus oxidation state. What is the oxidation state of zinc right here? It's +2 because NH3 is the neutral ligand. Oxidation state is +2. Plus number of ligands. How many ligands do we have? 4 ligands, right? Multiplied by this 2. What is the density of this NH3? Density of this NH3 is 1. It forms 1 coordinate bond at a time, right? When you solve this, you get the value as 36. So effective atomic number of zinc in this compound is absolutely going to be 36. I'm sure it's clear to every single guy, yeah? Exactly, guys. Perfect. Yeah, so remember this formula from now onwards. Remember this formula from now onwards. Perfect. Let's move on to one more question which is on your screen. Which of the following is the most soluble in water? Which of the following is most soluble in water? What do you think? People, as you all must be knowing, solubility, it depends on the two factors. It depends on lattice energy and at the same time it depends on the hydration energy. Lattice energy and hydration energy, okay? If I say something like this, solubility, remember, it's directly proportional to hydration energy, okay? And hydration energy is directly proportional to the charge present on the ion divided by size of the ion. Divided by size of the ion, correct? Over here we have got CS positive, Na positive, K positive, Li positive, right? Charge everywhere is same. Anion everywhere is same. ClO4 negative, ClO4 negative everywhere. Everywhere you have got ClO4 negative, right? I'm not going to decide on the basis of ClO4. I'm not going to decide on the basis of ClO4, correct? Now, charge on every cation is same. Let's talk in terms of size. Li positive has got the minimum size among these ions, among these cations. If Li positive has got the minimum size, its hydration energy will be maximum. If hydration energy is maximum, solubility is going to be maximum. So which one of the following will have maximum solubility in water? It's absolutely going to be option 4. Yeah? Right? Absolutely, guys. Just remember this statement. It's done. Yes? Perfecto. So it's going to be LiClO4, which is going to have maximum solubility in water due to maximum hydration energy of Li positive among all the cations. Yeah? Perfecto. Moving on to one more. And before moving on to one more, guys, do not forget to like the video. Do not forget to share the video with your friends, and do not forget to subscribe to the channel as well, right? Because I have promised you I'll be finishing some 30 mock tests, and today it's going to be our 14th mock test, right? Tomorrow in the morning at 9, I'll be doing the complete formula revision. In the night, we are going to have me, Shimon sir, and your Shreya sir. We are going to have the mega mock test tomorrow, starting at 4 p.m. Yes, and so on. Yeah. Okay, moving on to one more question. Okay, the increasing order of stability of the carbocations is, we are given with certain carbocations, we are going to arrange these carbocations on the basis of their stability. Can you give it a try? Let me know its answer in the chat box, yeah? Can you let me know its answer in the chat box fast? It's a very simple question, guys, yeah? It's a very, very simple question. Oh, Venkat, let me tell you, these are NTA questions. These are NTA questions. That means this is going to be the level of your JEE examination, JEE Mains examination, right? Understand? That's why I'm coming up with the NTA questions. Yes? This is NTA, proper mock test, official mock test. Yeah? Well, people are coming up with option B, is that? Let's give it a try. Let's see how this sort of equation is to be solved. So we have got C6H5CH2 positive, right? So this is basically your C6H5CH2 with a positive charge, correct? One more, it is C6H5. One more is your C6H5, this is CH2, and this is CH2, and over here we have got the positive charge, right? Yes. What about the third one? Third one is C6H5. This is C6H5, and you have got CH with the positive charge on this carbon, and on this side you have got CH3, correct? And the last one, what is that going to be? It's going to be like this. Last one is going to be like this, understand? This is C6H5, and this carbon having the positive charge, you have got one CH3 on this side, one CH3 on this side, correct? These are the carbocations which are given to me, right? First thing, is this positive charge in conjugation with this pi bond? Absolutely, it's in conjugation. So which effect will stabilize this carbocation? Resonance is going to stabilize this carbocation. Yes, resonance is definitely going to stabilize this carbocation. Yes, right? Similarly, if you look at this, is this carbocation resonance stabilized? It's not in conjugation with this pi bond, so it's not resonance stabilized. It's not resonance stabilized. Okay. If you look at this one, if you look at this carbocation, this is resonance stabilized, and at the same time you have got plus I group, okay, which will be decreasing the positive charge density on this carbon, increasing its stability. So over here two effects are operating. I mean, carbocation is getting stabilized by resonance, at the same time by plus I effect, right? And at the same time, if you look at the last one, this positive charge, it's in conjugation with this pi bond, yeah? And at the same time, two plus I groups attached. Yes, so two plus I groups attached. With these two plus I groups, we have got resonance stabilizing this carbocation as well. Yes, right? Now, you can give the order on your own. You can give the order on your own, right? I've given you the answer. I've given you the answers. Which one is going to be, let me first of all tell you, the fourth one is going to be maximum stable because the carbocation is getting stabilized by resonance and the same time two plus I groups, okay? So last one is the maximum stable. Last one is the maximum stable. Fourth one is maximum stable among all, right? Now, this one is having resonance, this one is having resonance. With the resonance, this is having plus I, correct? So now comes the third one, right? Now comes the third one. Now comes the first one. And at the end, we have got the second one, right? So this is going to be the stability order of the carbocations. I'm sure it's clear to everyone, right? So which all satisfies it? It's going to be 2, 1, 3, 4. 2, 1, 3, 4. This is option A, which is going to be correct one among all. I'm sure it's clear to everyone. Yes? Right? Let's move on directly to one more question. This is one more question. A very simple, basic, ordinary question. Yeah? Among the given species, F negative, O and O negative in the order of their radii. Okay, you need to arrange them on the basis of their, on the order of their radii, correct? Understand how it's to be solved. It's a very simple one. In case of O negative, how many electrons are there? 10 electrons, right? O negative carries 10 electrons, F negative 10 electrons, oxygen over here will carry 8 electrons, fluorine will carry 8 electrons, right? Yes, you know it. Correct? Can I say these two are isoelectronic species? These two are isoelectronic species. Let me first of all tell you, anion, the size of the anion is always greater than the size of its parent atom. Size of anion is always greater than the size of parent atom, correct? So these two are isoelectronic species. How many protons do we have right here? We have got 8 protons, we have got 9 protons, right? Okay. So O negative, wherever protons are going to be more, in the isoelectronic species, wherever protons are going to be more, size is going to be less. In the isoelectronic species, wherever protons will be more, size is going to be less, right? Okay. So among these two, which one is going to have more size? You will have maximum size is shown by O negative, then comes your F negative, correct? Now, among these two, among oxygen and fluorine, as we move along the period, oxygen to fluorine, what happens to size? As we move from left to right, size decreases, okay? So now comes oxygen, now comes fluorine. This is going to be the order over here. Right? Just reverse the order. It's going to be O negative, the maximum, then F negative, then O, then F. This is going to be the order of the radii. So which option satisfies it? O negative, then we have got F negative, right? Then we have got O, then we have got F. So option A is the one which is correct among all. I'm sure it's clear to everyone, right? Perfect. Exactly, guys. Yeah. Moving on to one more question. Calculate the normality, molarity and molality of the solution, okay, containing 22% weight by weight salt of this. People, without solving this question, we can give the answer of it. Yeah, without solving this question, I think so. Yeah. Yeah, exactly. Without solving this question, we can give answer of this question. And answer of this question must be option 4. Right? How come? As you all must be knowing, see, we are supposed to calculate normality, then molarity, then molality. So this is normality, this is molarity, and at the end, this is molality. As you all must be knowing, normality is equal to molarity multiplied by n factor. Right? We know it. Normality is equal to molarity multiplied by n factor. What is the n factor of Al2SO4 whole thrice? Al2SO4 whole thrice? The charge is +3, the charge right here is -2, correct? This is a salt, and what is the n factor of the salt? It is the LCM of charge present on cation and anion. LCM of charge present on cation and anion is going to be the n factor of the salt. So n factor is 6. So your normality will be 6 times molarity. Normality should be 6 times molarity. Molarity is 0.8 multiplied by 6. That is 4.83, right? Yes? Only one option. Correct? So this cannot be the answer. 8.25 multiplied by 6 cannot be 4.83, right? 0.825 multiplied by 6 cannot be 48 point something, right? Similarly, 4.83 multiplied by 6 cannot be this. Yeah? Right? Or if you want to solve this question, you can do that. If you want to solve it, you can do that by using formulas as well. First thing, I'll be calculating molarity. There is one direct result to calculate molarity. 10 multiplied by density of solution multiplied by weight percent of solute divided by molar mass of solute, right? Okay. So 10 is the constant. Density of solution is given to us. Is that? Yeah. Density of solution is given to us. Weight by weight percent of solute is given to us. You can calculate the molar mass of solute and get the value of molarity. Yes. Once you get the molarity, you'll be writing normality is equal to molarity multiplied by n factor. N factor is 6, so multiply with molarity, get the normality. And then at the end, you have to calculate molality. And there is a result between molality and molarity as well. Yeah. Remember, molality is equal to 1000 multiplied by molarity of the solution divided by 1000 multiplied by density of solution minus molarity multiplied by molar mass of solute. Correct? Molarity you have calculated from here. Density of solution is given to me. Molarity we have calculated. Molar mass of solute you can calculate. So from here you can get the molality as well. Yeah? Right? Yes? So this is how, this is what is the general approach. And it just came into my mind, there is only one option. over here, which satisfies the earlier conditions, right? So option D is the one which is going to be correct one among all, right? I'm sure it's clear to everyone. Moving on to one more. Which of the following is the example of the intensive property? Okay, all of you must be knowing extensive properties of the ones whose value changes on changing the size of the system, on changing the amount of substance present in the system. Whereas intensive properties are the ones whose value does not change on changing the amount of substance present in the system, right? Enthalpy, it's an extensive property. Its value changes on changing the size of the system. Energy, extensive. Mass of substance, extensive. Surface tension does not depend on the amount of substance, right? Surface tension does not depend on the amount of substance. Yes? Right? Surface tension, it does not depend on the amount of substance. For example, you have got a glass which has got the capacity of 10 ml. There is water in it. There is water in it. This is the top layer, okay? This is the top layer. Now, you have got one more tub which contains the same water whose capacity is 1000 liters, right? Over here, again, you have got same water. Whatever will be the surface tension of this water, same is going to be the surface tension of this water. Surface tension is independent of the amount of substance, right? Okay? As simple as that. And any property whose value does not change on changing the size of the system, that's something which I call as intensive property. So surface tension is the one which is intensive among all. I'm sure it's clear to everyone. Moving on to one more. A gas expands adiabatically at constant pressure such that temperature is inversely proportional to root of V, volume. The value of gamma, that is Cp by Cv of the gas, will be. See guys, again a very simple question. See first of all. Understand properly. So first thing, it's mentioned to me temperature is inversely proportional to square root of volume. It's mentioned to me like this, yeah? Right? Can I say T is equal to K divided by V raised power 1 by 2, where K is the constant? Or I can say TV raised power 1 by 2 is equal to constant. This is the equation which I got. But we know for adiabatic processes, do you guys remember TV raised power gamma minus 1 is equal to constant? Yeah? For adiabatic process, TV raised power gamma minus 1 is equal to constant. If you compare these two equations, can I say 1 by 2 is basically equal to gamma minus 1? Gamma minus 1 is equal to 1 by 2. So gamma is going to be 1 plus 1 by 2. That means 3 by 2. 3 by 2 means 1.5, right? So option B is the one which is correct among all. Yeah? Right? Exactly, guys. Perfect. Exactly. Wonderful. Let's move on directly to one more question, which is on your screen. A very simple and basic question again, guys, right? Calcium carbonate solid in equilibrium with calcium oxide solid plus carbon dioxide, right? In the closed container at equilibrium. So reaction is present at equilibrium. What would be the effect on addition of calcium carbonate on equilibrium concentration of... Guys, a very simpler one, right? See, this is in solid, this is in solid, this is in gaseous phase, right? Okay. For the solids, active mass is considered as 1. If you increase or decrease the amount of solids, right? This reaction is first of all taking place in the container. In the container, if you will increase or decrease the amount of these solids, nothing will happen to equilibrium. Nothing to happen to equilibrium constant, right? Nothing will happen to the equilibrium concentration of anything. Okay? So equilibrium, it remains unaffected. On the addition or subtraction of the solid, okay, in a chemical reaction, which is at equilibrium, right? Equilibrium remains undisturbed, right? Nothing is going to happen. Yes? Perfect, guys. Exactly. Moving on to one more question. Okay, this is one more question. Germanium plus 2 compounds are more powerful reducing agents, whereas lead plus 4 compounds are strong oxidizing agents. Even then belong to same group 14. This is due to. Simple question. Memory based one, right? Yes? Okay. What are group 14 elements first of all? Carbon, silicon, germanium, tin, lead. Okay. If I move from top to bottom, what happens to inert pair effect? Inert pair effect increases. Inert pair effect increases. Right? So if I compare if I compare germanium and this lead, which one will show more inert pair effect? Lead will show more inert pair effect, right? Yes? Right? I think the question is done and dusted. Yes? You got it? You got it? Perfect. So what is going to be the correct answer of this question? More powerful inert pair effect in lead than that of germanium. This is going to be the reason of it. Yeah? Very, very simple question this was. Perfect, guys. Wonderful. Moving on to one more. 2 moles of an ideal gas is expanded isothermally and reversibly from 1 liter to 10 liters at 300 Kelvin. The enthalpy change in the process will be. Very difficult question this is, guys. Very difficult question. Let me know its answer first. It is going to be 0. It's going to be 0, right? First of all, it's mentioned that the ideal gas is undergoing isothermal process. The ideal gas is undergoing isothermal process. If the ideal gas is undergoing isothermal process, temperature of the ideal gas is constant. If temperature is constant, delta T is 0. Delta H for the ideal gas, as you all must be knowing, NCP delta T. Since delta T is 0, that means this whole term becomes 0. So delta H is 0, right? So option C is the one which is correct. At the same time, delta U, which is equal to NCV delta T for the ideal gas, even this value will be 0, right? Yes? Exactly. Moving on to one more question then, right? Moving on to one more question. I'm sure it's clear to everyone. Moving on to one more. Okay. What will be the EMF of the following cell? I'm basically given with the hydrogen electrode. I'm given with the, I'm given with the cell, yeah? Okay. Let me just rewrite this cell like this. Let me just rewrite it like this. Platinum solid, yes, comma, H2 whose pressure is P1, getting converted into H positive, whose concentration is, for example, C1, right? It's salt bridge right here in between, right? It's salt bridge right here in between. It's H positive, whose concentration again is C1. It changed to H2, whose pressure is P2, right? And this is platinum solid. I have made the same cell in this way as well, right? Let's try to solve this. First thing, on the left hand side of the solid bridge, I write the anode. On the right side, we write the cathode, right? So this is the anode. And at anode, oxidation takes place. We know it. Oxidation means loss of electrons. H2 is getting converted into H positive. So the reaction should be H2, whose pressure is P1. It gets converted into 2 times H positive, whose concentration is C1 plus 2 electrons. This is the reaction taking place at anode, right? Similarly, what is the reaction taking place at cathode? The reaction taking place at cathode will be equal. Cathode means reduction. H positive getting converted into H2. So the reaction should be 2 times H positive with the concentration of C1 plus 2 electrons. It changed to what? It changed to H2, whose pressure is P2, right? This is the reaction taking place at cathode. People, can I simply add them up, right? Because the electrons in both the reactions are balanced, right? When I add them up, the number of electrons, the number of moles of electrons that are getting exchanged from anode to cathode is basically equal to 2, right? When I add them up, this term and this term got cancelled. So I got to know H2 whose pressure is P1 gives H2 whose pressure is P2, correct? If I want to write the QC expression, it's going to be partial pressure of this, which is P2, divided by partial pressure of this, that is P1. So QC is done. If I want to calculate the E0 cell, right? E0 cell is going to be 0 because it's a concentration cell. On both the sides, same electrodes, E0 cell. E0 cell for the concentration cell is taken to be 0, correct? Everything is done and dusted, yeah? Now use the Nernst equation. E cell is equal to E0 cell minus 2.303 RT divided by NF. N value is 2 divided by NF. It's going to be log of QC. QC is P2 divided by P1. QC is P2 divided by P1, right? Or let me write it in terms of ln form. So instead of this whole term, I'll be writing ln. Correct? So I'll be writing something as, I'll be writing ln, or let me write it like this, just a second, is equal to minus 1 divided by 2f. It's going to be ln of P2 divided by P1. Correct? Or just take the reciprocal of it. It becomes 1 divided by 2f. It's going to be ln of P1 by P2. Yes, this is going to be the final answer of the question. Yes? I think I forgot to write RT. Where is RT? This is RT. And this is RT. RT divided by 2f ln of P1 by P2. RT divided by 2f ln of P1 by P2. Which one option is that? It's going to be option 2. Yeah? Right? Perfect. Absolutely, guys. It's going to be option B. Yeah? A very simple question this is. Correct? Option 2. Moving on to one more question. Arrange in the decreasing order of their boiling points. Oh my God. This is again a very tough question. Give it a try and let me know its answer. Very, very tough question this is. Let me know fast. And the ones who have not liked the video yet, please and please do like the video, share the video with your friends, and do not forget to subscribe to the channel as well, yeah? Right? What is going to be the answer of this question? People, it's a very simple question, right? Boiling point depends on the molecular mass, right? More the molecular mass, more is going to be the boiling point. Molecular mass of this substance is maximum, its boiling point is maximum, followed by this, followed by this, followed by this. So 4, 3, 2, 1 is going to be the order. 4, 3, 2, 1 is going to be the order. So option B is the one which is correct. Yeah? Yes? Perfecto. Let's move on to one more question. The gas leaked from a storage tank of Union Carbide plant in Bhopal gas tragedy. My God. Okay? And people, trust me, these sort of questions are asked nowadays. These sort of questions are asked nowadays. Yeah? These sort of questions are asked nowadays. In the Bhopal tragedy, okay, it happened, I guess, in 1984. Yeah. This tragedy happened in 1984, I guess. And over 500,000 people were affected. Over 500,000 people were affected. By what? By methyl isocyanate. Okay? By methyl isocyanate. Yeah? These sort of questions are asked nowadays. Exactly. Perfect. Moving on to one more question. In the given reaction X and Y are. In the given reaction X and Y are. Okay? So we have got some C6H5. This is C6H5. This is O. With this O, you have got CH2, CH3 attached over here. This oxygen has got 2 lone pairs, right? We know it. We know it. In presence of HI, in presence of HI and heat, in presence of HI and heat, what is going to happen? This is basically H positive, this is basically I negative. Simply do one thing. Attach this hydrogen with oxygen and attach this iodine with this thing. So what you get as the result over here, I'm not going to show you the mechanism or something, just remember it like this, just remember these tricks. Attach this hydrogen with this oxygen, yes, and attach this iodine with this CH3, CH2, CH3, CH2 and I. These are the products over here which I got, right? Okay, so you got C6H5OH as X, C6H5OH as X, and CH3CH2I as Y. Yeah, so option 2 is the one which is correct among all. Yes? Perfect, guys. Exactly. Let's move on to one more question. In the reaction XA gives YB, there are some parameters given to me. Find the values of X and Y. Again, a very simple question, yeah? Let's try to solve this one. Have a look. This is the reaction given to me, yeah? Let me write its rate, differential form of rate. I can say -1 divided by X, -1 divided by stoichiometric coefficient, change in the concentration of A divided by dt. This should be equal +1 divided by Y, change in the concentration of B divided by dt. Correct? This equation all of you must be knowing. Yes? This equation all of you must be knowing. Now we will understand. This is one parameter that's given to me. Correct? See what I'll be doing with this parameter. It's simple thing. See guys, I'll be writing log of -d of A divided by dt, yeah, is equal. This is log of plus d of B divided by dt, yes, plus, this is 0.3, correct? What is 0.3? Can I say 0.3 is basically log of 2? 0.3 is basically log of 2 to the base 10, yeah? Now use basic maths. It's log of -d of A divided by dt is equal. This is log of m plus log of n, which is going to be log of m into n, correct? Log of 2 multiplied by d of B divided by dt, something like this, yeah? Take antilog on both the sides. It's going to be -d of A divided by dt is equal to 2 times d of B divided by dt. Just take this 2 in the denominator over here. It's -1 divided by 2. D of A divided by dt is equal to d of B divided by dt. People, just compare this equation and this equation. Compare the two. Compare these two equations. You are getting the value of x as 2. You are getting the value of y as 1 over here. X is 2, y is 1, right? X is 2, y is 1. So 3 is to 1, yeah? Option C is the one which is correct. Clear to everyone? Is it clear to everyone? Let me know in the chat box fast. If it is clear to everyone, fast, guys. Yes. The ones who have not liked the video yet, please do like the video, share the video with your friends, and do not forget to subscribe to the channel as well, yeah? Perfect, guys. Perfecto. What did I do? Did I do some mistake? I've done some mistake, yeah? What was that? Okay, it was 2 is to 1. It was not 3, sorry. It was 2 is to 1. X was 2, X was not 3. X was 2, 2 is to 1. Yes? Perfecto. Let's move on to one more. Okay, what will be the sum of principal and azimuthal quantum number for the last electron of argon? Okay, so we have got argon, right? We have got argon. Yes, we have got argon. Its outermost electron, its outermost configuration is 3p6, right? Its outermost electron is 3p6, we know it. Yes? Correct? Its outermost electron is in 3p6. Argon is a noble gas, right? Helium, neon, argon, correct? Atomic number 18. So 3p6 is the configuration. If I talk about the last electron of argon, 1, 2, 3, 4, 5, 6. This is the last electron. This last electron, it is in principal quantum number n is equal to 3. Yes. And it's in p subshell. For p subshell, the value of L is 1. So 3 plus 1 is 4, right? That's something which I was supposed to calculate. What will the sum of principal quantum number azimuthal, right? 3 plus 1 is equal to 4. So 4 is the sum of the two, which is something I was supposed to calculate, right? Perfect. Wonderful. Let's move on to one more. At what temperature is the RMS speed of hydrogen molecules the same as RMS speed of this and this? Okay, very simple. As you all must be knowing, RMS speed is basically equal to under root of 3 RT divided by M. This is how we calculate RMS speed. Now it's mentioned in the question, at what temperature? At what temperature? RMS speed of what? RMS speed of hydrogen. RMS speed of hydrogen becomes equal to the RMS speed of oxygen, correct? RMS speed of hydrogen, I can write it as under root of 3R temperature of hydrogen divided by molar mass of hydrogen, yes, is equal to under root of, this is 3R temperature of oxygen divided by molar mass of oxygen, right? Root cancel, 3R cancel, is going to be temperature of hydrogen, which is given to me, right? This two, this cancel, root cancel, temperature of hydrogen. Temperature of hydrogen, at what temperature is the RMS speed of hydrogen? Okay, temperature of H2 I'm supposed to calculate. Molar mass of hydrogen is 2 grams per mole is equal. Temperature of oxygen is given to me as 1327 degrees centigrade. 1327 degrees centigrade plus 273. It's going to be 07310 31426. It's going to be 1600 Kelvin, right? 1600 Kelvin divided by molar mass of O2 is 32. All of you must be knowing, correct? So its value is going to come as 100 Kelvin, right? Value is going to come as 100 Kelvin. It's going to be 3200 divided by 32. The value will be simply 100 Kelvin. So when the temperature of H2 is kept 100 Kelvin, then only its RMS speed will be same as that of RMS speed of oxygen at 1327 degrees centigrade. Isn't it simple? Yeah? Isn't it simple? Perfect, guys. Exactly, it's 100 Kelvin. Okay, moving on to one more. Okay, it looks complicated. Is that? Identify the total number of atoms in the product Q in the following sequence. Okay, we are given C6H5NH2 in presence of NaNO2 plus HCl. It gives something X. So X on further reacting with Cu2, Cn twice, it gives Y. Then its hydrolysis happening. Then it's, okay, decarboxylation is happening. Yes. Then at the end, chlorination is happening. Okay, see guys. So first of all, we are given with aniline, right? The first reaction is the diazotization reaction. What is the X over here? X is something which I call as benzene diazoxide chloride, N2Cl. Benzene diazoxide chloride, this is my X. Now it on reaction with what? It on reaction with Cu2, Cn2Is, correct? What do we get? What do we get? Just replace this whole thing. Instead of it, place just Cn. We get cyanobenzene. We get cyanobenzene over here. This is Cn, right? Now what is the next step? I'm going to do its hydration. I'm going to do its hydration. So from cyanobenzene, you get benzoic acid, right? You get benzoic acid. Now this benzoic acid, I'm going to do its decarboxylation, right? In presence of NaOH and CaO. So it will simply get converted into benzene, right? It will simply get converted into benzene. So P is benzene basically. Now in presence of excess of Cl2, what do we get? In presence of excess of Cl2, what do we get? We get something as C6H6Cl6, right? So how many atoms are present in this? 6, 6, 12, 6, 12 plus 6 is 18, right? This is excess, guys, yeah? Right? So what is going to be the answer of this question? It's going to be 18. 18 is the answer of this question, right? Your first reaction was the diazotization, then we have got the Sandmeyer's reaction, right? Followed by hydrolysis, and at the end, followed by decarboxylation, right? Then photochlorination, yes? Right? Perfect, guys. Moving on to one more then. This is one more. This is again a very tough question, yeah? In case of your Friendly's adsorption isotherm, you know x divided by m, right? You know x divided by m is either written as k p raised power x, or you write the same thing as x divided by m is equal to k p raised power 1 by n. You can say 1 by n value, it lies between what? It lies between 0 and 1, right? Or you can say x value lies between 0 and 1. Yeah? It's 0 to 1, correct? I'm sure it's clear to everyone. So it's going to be 0 to 1 is the answer of the question, absolutely, right? So the value of 1 by n, it lies between 0 to 1 in all the cases, you know it, yeah? Perfect. One more question from the chapter solution. The vapor pressure of acetone at 20 degrees centigrade is 185 torr, yeah? Acetone is the solvent which I'm using in this case, yeah? And vapor pressure of solvent in pure state, I'm representing by P naught A, is given to me as 185 torr. Okay, when 1.2 grams of a non-volatile solute was added. So non-volatile solute, mass of non-volatile solute which I'm adding is 1.2 grams, yeah? When 1.2 grams of a non-volatile substance is added in 100 grams of acetone. So what is the mass of solvent? Mass of acetone is 100 grams, correct? Its vapor pressure was 183 torr. So vapor pressure of solution after adding non-volatile solute to acetone, its vapor pressure became 183 torr. What do I need to calculate? Molar mass of the solute. Molar mass of the solute. How do I do it? Very simple. I'll be using the equation P naught A minus PS divided by PS. It is equal to NB divided by NA. Right? You must have seen this equation as well, yeah? What is the value of P naught A? P naught A value is given to me simply as 185 minus PS. PS value is given to me as 183 divided by PS, which is 183, is equal to NB, number of moles of solute, which is going to be equal to mass of solute, 1.2 grams, divided by molar mass of solute, which I'm supposed to calculate, whole divided by Na. Na is the mass of solvent. Mass of solvent is 100 grams, divided by molar mass of solvent. Molar mass of acetone. Guys, what is the molar mass of acetone? Can you let me know fast? What is the molar mass of acetone? Let me know in the chat box. Molar mass of acetone. Fast, fast, fast. Let me know. Molar mass of acetone. People are saying 58. Okay. Now everything is in front of you. You are supposed to just calculate this MB. And let me exactly tell you, MB value after solving, you'll be getting it exactly to be 64 grams per mole. So molar mass of your non-volatile solute, it comes out to be 64 grams per mole. Yeah? Clear to everyone? Okay, so people, with this, today's mock test is done and dusted. One more thing. As you all must be knowing, your fourth shift of your JEE 2021, it got postponed in August. Yeah? Now people, again, you have got ample time to do the preparation if you think your preparation is not up to the mark right now for the third attempt. Now, and for that, what we have come up with, the JEE 2021 crash course, right? In this crash course, we'll be covering your whole syllabus. Yes. It's not only about the syllabus coverage of your physics, chemistry, and maths. There'll be mock tests involved in it, right? There will be test series involved in it. It's a complete package. There will be some extra sessions with the experts who will be helping you out to solve the questions in lesser time, right? Who will be making you familiar with the exam culture, right? So people, the best and the last option for you guys to shoot up your JEE rank is to enroll in this crash course. How do you enroll in this crash course? Well, let me show you exactly how you enroll. There's a link in the description box of the video. You need to click on that link. You need to use the coupon code as WSCC. After using the coupon code WSCC, you'll be getting some 40% off, 60% off. And after the 60% off, you're just getting this crash course for 4K. And let me show you exactly how to use this coupon code and all. So people, this is the channel. This is our JEE Enthuse channel, right? Okay. So is this the video which is currently going on? Which video is currently going on? So this video is currently going on, yeah? You simply need to click on the description box, right? This is the everything which is there in the description box. After click on the description box, you can take this crash course. This is a link for the crash course. If you just want the test series, you can click on this link. Let's say I need to take the crash course. You need to click on this link. After clicking on this link, right? What you need to do is you need to click over here buy now, right? After clicking on that, you just need to use your email ID or phone number on which OTP comes and everything will be done, right? So this is how you can enroll in the crash course and do it as soon as possible because the time is less, right? And trust me, it's going to be highly, highly, highly beneficial for you. Yeah? There is one more link in the description box of the video. That's for the Telegram. Do click on the Telegram link, right? Get added to the Telegram group and stay updated about the classes. And the ones who have not liked the video yet, please do like the video, share the video with your friends, and do not forget to subscribe to the channel as well. Yes? Right? Yes, Sivaraj, I'll be coming in the crash course. Yes. So with this, I'll take a leave. I'll see you guys tomorrow in the morning. Tomorrow in the morning, we are going to do the formula revision. Do not miss that at any cost, right? It's going to be highly beneficial for you. Whatever formulas are there in chemistry, I'm going to finish all those formulas just in 1 hour, right? Okay, in 1 hour, I'll be giving you all the formulas which are needed in your physical chemistry, okay, and other formulas as well. Okay, so let's speed up in the morning. Till then, you take care. Bye-bye. God bless you all and love you all. Take care, guys. Bye. Yes, Jay, I'll be teaching there in the crash course. Yes, exactly. Do it as soon as possible. Bye-bye.